Awesome. So, welcome to the August edition of virtual Kubernetes Meetup from Bangalore. And yeah, so since this is a new normal now, this is how we'll be doing most of our meetups. Earlier, we used to do a lot of theme-based meetups where there was this one theme, like let's say networking or containers and or whatever, container runtimes, etc. But now, for keeping the meetup shorter and for any kind of speakers that we are getting, we resorted to doing general meetups and not having a theme based ones. Uh, Otherwise, this meetup happens every monthly. If you're new, you should know that if you follow our Twitter handle or the meetup page, we do it every one Saturday in a month. Why Saturday? Like this has a historical thing. Uh, when we were doing like physical meetups, it Saturday was a feasible time to do it. We might try doing a weekly meetup now that we are all virtual and anybody can join at any time. So yeah, haven't really tried it. We'll try that. Apart from that, K8SBLR is our Twitter handle. If you want to tweet, like just reach out to us there. And just one thing I want to mention, when you are commenting on the YouTube comments, please make sure you're decent and like any criticism you want to post, please be constructive about it. Don't basically have some decency out there. Our speaker today is Steve. He comes to us from London. Thanks to the virtual meetups, now we can have speakers from all over the world. He works for Metal, and he's a consultant and also a trainer there. And he's very active upstream. If you have seen, I have come across many tools that he has created, especially using the OPA, like finding out what versions of manifest are older and stuff like that. So I have used some tools that he has created.
We'll talk about that today.
Oh, awesome! Yeah, we'll get to know more in detail about it. And he is also an active speaker. He presents in multiple meetups. I've seen him, and today he'll be talking to us about Metal's journey towards through oil clusters. So over to you, Steve.
Okay, let me share my screen. Can everyone see my screen okay? Perfect. So for the next about 30 minutes, I'm going to talk to you about the journey that Metal, which is a company that I work for, has been on, specifically around GitOps. So as Shivraj said, I am an independent consultant and trainer, and I'm currently platform lead at Metal. I've contributed to a number of tools. Flux is the main one that we're going to talk about today. A lot of this is kind of theory-based. We're going to get into a little demo a little bit later. But I blog quite a lot about some of the kind of more technical details and implementation. So feel free to have a read after this meetup. So what is Metal? So Metal is a business bank account, but it's completely digital. So you can't walk into a building and ask to speak to someone. It's all done via a handset, via an application on your mobile phone or on your tablet. So I want to start with this quote. So the quote by Kelsey. And Kelsey says, "Once you've found success, your next goal should be helping others to do the same." So I replaced the word success with a pattern that works. So at Metal, we found a pattern that works really well around GitOps, and it's enabled us massively to increase innovation. So the rest of this talk is really going to be around that journey, and hopefully you can take something away and use this pattern within your organization. So the agenda for today is we're going to start with this unanswerable question. So this unanswerable question was a question that I was asked, and I was unable to answer it. And then how did we redesign and re-architect what we built? Then how do we structure our repositories, specifically our GitOps repositories? And then we'll take a look at what does continuous delivery look like for us. So both from an application perspective and also from a Kubernetes resource perspective. And then how does it kind of all tie together? So how do we bring applications and this GitOps pattern together to be able to enable us to create platforms for Metal? And then finally, can we answer the question now that we couldn't answer in the past? So for any of you who are familiar with large banks, specifically ones that are based out of the UK, it's a lot of guys in suits, and it reminds me a lot of Wolf of Wall Street. But the real thing that's the problem with kind of large, big banks is that they have this concept of red tape. And what red tape is their inability to be able to move fast. So they have a lot of compliance, they have a lot of regulation, and this really slows them down, right? They can't deliver new features to their customers, and they're very, very risk averse. They don't like to take risks. So once Metal got spun up, so Metal, to kind of clarify, is a company inside a larger bank. It's kind of what's known as a venture. And it is to show NatWest, who is the larger bank, a new way of working and a new way of delivering value to their customers. So what happens with that is we get a lot of people looking at us. And if you imagine these people that are on the screen as the kind of bank that we were associated with, they were looking at us. They wanted to know what we were doing. Why are you doing this? And then from that, this happened. So this is me at meetings with the wider bank being asked a lot of questions, right? How are you doing things? How are you deploying, et cetera, et cetera, et cetera. So one of the questions that we got asked was, how long would it take you to rebuild an environment? Pretty simple question, right? But I just kind of shrugged. I said, well, actually, I don't know. Why do I need to know, right? We're running on top of Kubernetes. Kubernetes does desired state. I can lose a node and a new one comes up. We know how to do that. We can lose a replica of a microservice and a new one comes up. But we've never really needed to worry about this before. But that wasn't good enough for them, right? They're the ones that pay the bills. They pay me to be there. So we have to be able to answer this question. And we just couldn't answer it. So we went on this rebuild process and we rebuilt the platform kind of from the ground up. And we always started with this mission statement. So the team that I was leading and I'm leading now, we started everything from this statement. So this statement said that the platform that we wanted to build needed to provide an easily recoverable, consistent platform with clear ownership and, most importantly, self-service to developers. So if we can hit these points, we can we have the ability to be able to prove to the wider bank that we can be easily recoverable. And we've split out this ownership model. So developers are responsible for the things that they care about, and platform engineers are responsible for the things that they care about. So at a high level, we kind of have this kind of structure. So we start in Amazon. Everything we do is in Amazon with regards to the platform. We then layer Kubernetes on top. And then on top of that sit the Metal workloads. It's pretty simple, right, in theory. So we had this kind of decision to make. So we realized that GitOps was going to give us a lot of this stuff. It was going to allow us to be able to define our desired state in Git, and then it was going to be reconciled inside the cluster. So we had a choice, either Flux or Argo. So let's take a look at Flux. So what Flux is going to do is it's going to allow us to be able to sync. You can see in the kind of middle block there from Git. And it's also going to be able to pull new images and deploy those as well. But what we wanted to do is we didn't want to change drastically the developers' CI pipelines. We wanted to embed GitOps into their process. We didn't want to rewrite their process. right? If we rewrite their process, they are so used to the current pipelines and the way they deploy that it would be too much of a change. So the thing that we wanted to do was enable them to move faster. So we wanted to hook GitOps as a kind of methodology and pattern into their existing pipeline. So we chose Flux because it had this reconcile loop. It had this polling loop that would allow us to be able to sync changes into the cluster. So we know now with Flux and with the GitOps paradigm that we are going to be able to easily recover. If we can get this right, we store all of our configuration in Git and we reconcile it with a number of Flux instances, and then we are back to where we were. So that's the first step. Now on to the consistent part. The consistent part works from a three-character environment prefix. And we use this three-character environment prefix throughout the whole of Metal in engineering. We do it with DNS. We have it in our GitOps repository structure. And then finally, we have it in the microservice image tags that get deployed into our platform. So now, as long as we align to that three-character environment prefix, we are going to get the consistency that we want. So clear ownership. So with ownership, we have to split up our repositories in such a way that different people are responsible for different components. So the kind of analogy that I like to use is, we're all working towards a common goal. We all succeed together and we all fail together, but we're just working on different parts of the machine and we're responsible for different parts. So how do we structure the repositories in such a way that they have the right owners, they have the right people looking at them, right? I can't look at 15 repositories and approve all the PRs. It's just too many. So how do I focus my time from an approval perspective on the PRs that really matter and that I should be looking at, and then leave other ones to people that are more aligned with those. So before we go any further, I want to kind of talk about another component called the Helm operator. So for any of you that are familiar with Helm, you may have been familiar with kind of running commands such as Helm upgrade or Helm install or Helm delete or Helm rollback. But you were doing that from a centralized location. So that may have been your laptop, or that may have been some kind of CI/CD machine, maybe Jenkins, something like that. So what the Helm operator does is it allows us to be able to define something called Helm releases. And Helm releases are custom resources that we can deploy to Kubernetes. And then the Helm operator is an agent that sits inside of Kubernetes and is responsible for turning those Helm releases into kind of releases that are actually deployed inside of the Kubernetes cluster. So if we kind of go back a little bit to the old platform and the platform before we redid the rebuild, all the applications were deployed as Helm. So the developers had this understanding of Helm already, but what we needed to do is put it into a GitOps way of thinking. And this is where the Helm operator is going to enable us to be able to do that. So for any of you that are not familiar with a Helm release, this is a really, really straightforward Helm release. So a Helm release starts with a release name, and that release name has to be unique across the whole entire cluster. And then we have a chart. So a chart needs a repository. That repository could be a URL, or it could be a link to somewhere on GitHub or Bitbucket. And then the chart name that you want to deploy, and then finally the version that you want to deploy of that chart. You can also add annotations to your Helm release. And here we are basically saying that when we set automated to true, we want Flux to go and look for new image tags, in our repository, and reconcile those into the cluster and deploy them. So you can see here that we've set automated to true, And then we are looking for images that align to this semantic version. So in this scenario, 3.0. So if we created a new image of 3.0.1, Flux would go and see that, deploy 3.0.1, and then finally write back to Git. So let's have a look at some of the repositories. So let's start with Kubernetes resources. So Kubernetes resources, if you want to think about it like this, is the repository that is for platform engineers. So everything from the logging stack, the monitoring stack, all of our role-based access controls, so that developers only see what they need to within the cluster. So this repository uses a tool called Customize. And if you're not familiar with how Customize works, essentially you start with a base and then you override or patch base files with environment-specific configuration. And when I come onto the demo after the presentation, this is going to make a little bit more sense. So here is our customized directory inside of Kubernetes resources. So we have an underscore modules directory, and that's where all of our non-environment specific configuration lives. And then we have a number of environment directories. So if you remember back to that 3-character prefix that we were talking about before, we now have that, and we're now seeing that inside of our repositories. So dev dev for our development environment, PRD for our production environment. So inside modules, you'll see that we have a number of different directories, and these could be for a number of different products. But essentially, these are a set of directories that may or may not be deployed to an environment. So essentially, think about it as kind of a pick-a-mix. So you can choose what ones you want to deploy into an environment, and you can choose which ones you don't want to deploy. So a prime example is that every environment is going to use the cluster directory, but not every environment may use the docs directory or may not use the Istio directory. So let's take a look at Istio as an example. So in the dev directory for Istio, we're going to deploy Prometheus. And the difference here is that in the dev directory, what we are doing is we are passing in the dev specific values. So a lot of the configuration is performed in base. And all that we have in the environment specific directories are the values that make it work in the environment that we're trying to deploy into. So that's gonna give us a good basis, right? We're gonna have a monitoring stack there, we're gonna have a logging stack there, but everybody asks this question about what are we gonna do about secrets, right? Secrets is always this unanswerable question. It's a difficult question to answer. So for us, Flux plus sealed secrets equals awesome. So how sealed secrets works, if you're not familiar with it, is it works on a public and private key pair. So inside the Kubernetes cluster, you run the sealed secrets controller, and that uses a private key. The public key sits inside Git, and you seal secrets with a public key. You commit those to Git, and the only thing that can unseal them is the controller that is inside of the environment that has the corresponding private key. So now this is going to allow us to be able to store secrets in Git and use Flux to be able to allow us to reconcile them. So here is that repository. And inside sealed secrets, again, you'll see that 3-character environment prefix. It's going to run through all of these repositories. And an example here again is dev. So we've now got the platform workloads. We've got a way of getting secrets into the cluster. Now, how do we get metal releases or the kind of custom workloads that run the products that we are responsible for? So we have another repository called K8's releases metal. This repository, if you remember back to Kubernetes resources, looks very similar to that. They also leverage customize here as well. But now what you'll notice is inside this customized directory, they have base, but they only have the environments that they need to deploy to. We broke our 3-letter environment prefix for tools because if we called it TLS, everybody's going to get confused for obvious reasons with certificates. So let's just take a look at their base directory. So their base directory has a number of different products now. So we have a number of different products at Metal. Evie is the main bank. Identity is for us to know more about our customers. And there are a couple of other products here that we have as well. So let's take the account balance microservice and look at it from a base perspective. So you'll see that we have that annotation automated true because we want to look for new images and we want to deploy them. So think continuous delivery. We have a chart. All of our backend microservices use a backend chart for consistency because we don't want or need all of our developers to become Kubernetes gurus. We just need them to be able to understand the values file of our backend chart. And then finally, we now start to have some configuration for the application in the values. So look at lines 14 to 18. There's a couple of things you may have picked up on here. There's no chart version specified here. That's because the chart version is specific to the environment that we are deploying into. So if you think about it, if we have a 114 cluster and a 116 cluster, in Kubernetes 116, they deprecated a lot of APIs. So we had to change the Helm chart. So for us to be able to do that, we changed the chart version from a 1.x to a 2.x. And then we know that we are drip feeding changes through different environments by knowing the version of the chart that is currently being used. So I think we've got a couple of questions here. So one of the questions is the reference material available in Git or somewhere else? Yes, it is. We're actually going to do a demo of something very similar to the structure that you see here. It's a publicly accessible repository, and you can fork it and go and have some fun. And Savaraj's question is, are you using Customize before the Helm operator? How does the Helm operator work with plain YAML files? Does it not need Helm charts? So there's a key thing to note here, that Flux is reconciling resources. Those resources could be straight up YAML files, so think of RBAC, or they could be this concept of Helm releases. When we deploy the Helm release via Flux, the Helm operator is the thing that is responsible for turning that into an actual deployment. Whereas with RBAC rules, Flux is just talking straight to the Kubernetes API and deploying those. So Helm releases, Helm operator, non-Helm releases, the normal way of deploying. And I'm going to come on to that. We're going to have a little diagram. And then another question is, can you use Helm hooks with Customize? I'll continue going. If you can add another comment of exactly what you mean there, maybe with an example, I'll help. So whilst we're waiting for that, there's no chart version here, as we've just explained. But there's also no image tag. And the reason for that is because, again, the image tag is specific to the environment that we run in. So now let's look at one of the environment directories. So let's take dev. And if we go to the same account balance Helm release, but for dev now, there are a couple of things that you're going to notice. We're going to be telling Flux that we want it to update when we see changes to our image tags that are anything that follows the prefix dev-star. when we create new images, we tag them with dev dash and then the long commit SHA from Git. So what this means is, if you think about it, is from a CI perspective and a CD perspective, now all we need to do is tag images and upload them to the repository. And then Flux is going to do the rest. And then finally down here, you're going to see the chart version. Okay, so I think we've got another question here. So for example, pre-install hooks that create DB, for example, post. Yes, so the Helm operator, to be clear, is going to deploy the Helm chart. And if your Helm chart has tests in it, those tests will run. It's all the Helm operator is doing is a Helm upgrade, a Helm install, a Helm delete, or a Helm rollback. It's doing the same thing that you were used to doing before. The only difference is that you're not doing it. There's an operator inside of the cluster that is responsible for doing that. If that doesn't answer your question, then please let me know and I'll answer it again. So now we have this structure for deploying workloads into Kubernetes for our Metal applications. So there's a couple of other other files in this directory that I want to show you. And the main one really is this Flux patch. So what this Flux patch does is, if you think about that image annotation, every time Flux deploys a new image tag based on that annotation, it writes the change back to Git, telling you that it's performed an upgrade. Pretty awesome, right? I had to put the Queen in here. I'm British. I'm sorry. So that's great. So now how do we perform continuous delivery, right? So we've got all these repositories. That's great. We've got ways of deploying different kind of workloads, but how do we consistently make changes? So let's start with the microservice pipeline. So let's imagine that we are developers. Developers have a Git repository. We use GitHub extensively, and they use Concourse. So Concourse was their tool of choice. So that's the tool that we embedded GitOps into. So the first thing they do is they perform a Docker build. And that Docker build is with a tag of dev-commit SHA. Then they do a Docker push, and that ends up in our Docker registry or our image registry with a tag of dev- in this example, 1234. So we've got that image tag in our image registry. And we know that Flux is inside the cluster and is polling and looking for new image tags, right? Because we've got that automated true flag. So let's assume that it's found the new image from the image registry. It patches the Helm release. So here's a key thing to note. It patches the Helm release locally to the pod where Flux is running. So Flux has the understanding of everything that you're trying to deploy. It patches it manually with the new image tag. It then performs the kubectl apply, and then it commits the changes back to Git. So this is kind of the flow every time we see a new image. Inside Concourse now, after they've uploaded their new image tag, they are essentially waiting for an update. And they have a script that has a very specific set of kubectl commands that essentially is their way of knowing whether the rollout has been successful. Then they perform some testing in that environment. And then to go to staging, they do another build, or essentially they re-tag the image with stage-commit SHA. And then essentially they test, rinse, and repeat, right? So that's our way of being able to deploy it all the way up to production. So production, same thing, but we just have a PRD tag instead of a DEV tag. So that's great. Now we have a way of being able to deploy microservice changes. All of our developers are happy. Awesome. But now what about Kubernetes manifests? How do we do that? So for Kubernetes manifests, like the repositories that I've just showed you, we leverage Circle CI. And we run a set of checks. So the first set of checks that we run, and Shivraj was talking about this at the beginning, is a set of policy-based checks. And those policy-based checks are looking for a number of different things. So the main ones that we look at are the use of deprecated APIs. So what this has allowed us to be able to do is in CI, as part of the pull request process, we are making sure that what you're trying to deploy will work in the target environment. So we're running 117 at Metal, but we are doing deprecation checks against 1.20. So we know that we can deploy what we have right now to 1.20 and it wouldn't break. Then we run kubeval. So kubeval, for anybody that doesn't know, is performing strict linting against the upstream Kubernetes API, so the JSON schemas. And we run it in strict mode. So what that means is if you're trying to deploy a deployment or a daemon set, and you add a field that is not valid, it will break CI, and it will tell you that you've added a field that's not valid. So all we're doing here is we're getting more confidence before we deploy to the target environment. And then the final one that we run is we run HRVal. And essentially HRVal stands for Helm Release Validation. So how this works is it takes your Helm release, it goes and gets the chart and at the version that you've specified in your Helm release. And then it does a Helm template, but passes in your values that you've got as part of your Helm release. And then it runs kubeval against it. We took that a little bit further, and we actually also run all of our conf test or our policies, or compliance policies, against those outputs as well to make sure that we are compliant. The reason why we do this is because the thing that you're actually deploying is the Helm release. We're really using conf test and kubeval mainly inside of our Helm chart repository. And we're using HRVal in our kind of Kubernetes resources repository and our K8's releases Metal repository, because that's where the Helm releases live. So that's great. You've got a couple of clusters, you've got a couple of repositories, you've got some CI. That's fantastic. But like, how do you actually get this thing to work? So now I want to talk you through how we bring the cluster up. So we start with Amazon and we have Terraform there. And then on top of that, we created our own version of Kubernetes. We don't use any of the managed services. And we deploy this using Bootkube. And Bootkube, for any of you that don't know, essentially allows you to be able to add manifests for cluster creation. As part of that process, we deploy a Flux instance inside Bootkube. So the first time the cluster comes up, there is a Flux instance. And the Flux instance is pointing at Kubernetes resources. So here's an example of what that looks like. So we need to give it a Git URL. We need to give it a branch. We always track master. But the key things to note here is we pass it a directory. And that directory or path inside of the Kubernetes resources repository is the environment that it's going to reconcile. So if you were watching closely, you would have noticed a directory in here that I didn't talk about. And that directory that I didn't talk about is this Flux directory. So let's have a look at this. So inside this Flux directory now, we're going to have a number of other Fluxes. So we've got the Bootstrap Flux. So Flux can also upgrade Flux. So the Flux that we deploy as part of Bootkube gets overwritten with the Flux that's deployed here or configured here. Then we have a Flux for engineering. So that's the one that points to K8's releases Metal. And then we have a number of other ones for secrets, etc., etc. So now what happens is that first Flux instance comes up as part of cluster creation. And then a Flux comes up for K8 releases Metal, deploying our Metal workloads. We have another one for Kubernetes secrets that deploys all of our secrets for our environment. Another one for Kafka topics. So we are heavy users of Kafka. So we define all of our topics as resources inside Kubernetes. All of our Calico network policies get deployed as well. And then finally, we have all of our Istio resources. And then all of those come up at some directory / environment prefix. So now what we have is a way of being able to stand up the whole entire platform from a single Terraform command. So we run Terraform apply for dev. The infrastructure comes up. Kubernetes resources Flux comes up. All of these other fluxes come up, and then finally we're in a position whereby the platform is ready, or the environment is ready. So can we answer this question? So if we go back to the beginning, the question was, Steve, how long would it take you to redeploy your environment? So yes, we can. We can answer that now. And from a complete outage now to a fully working platform that has everything available for us to be able to run, it takes 25 minutes. So that's mission complete, right? That's essentially exactly what they wanted us to be able to answer. We now have a way of being completely self-service. Our developers can now deploy workloads whenever they want. We are completely out of their way. So just to give some kind of numbers, last month, our developers did 220 deploys to production, and 220 of them were successful. And the reason why they're successful, in my opinion, is because the developers are now focused on the thing that is important to them, which is the integration, the continuous integration, or the testing of their microservice. They don't have to worry about how the deployment gets handled. So they're focusing in the right areas, and the platform team are focusing in the right areas as well. So Savaj has got a question. Any specific reason to use Bootkube and not kubeadm or kops? So for us, it was around how we could maintain and keep all of the YAML files or resources that we wanted in a centralized location. So we actually have them in a separate repository. And then what we do as part of the Terraform execution is we go and get those manifests. We override them with a couple of values. So think of things like the image tag that you want. So Kubernetes 119 or 118 or something like that. And we don't want to push changes via Terraform into Kubernetes, right? We want it to be a one-time execution path. So we pull those in, create essentially a tarball with all of the manifest that we want, upload that to an S3 bucket, and then as part of the bootstrapping process, we pull down the S3 bucket. We pull down the tarball from the S3 bucket and start the reconcile loop. And the main reason for that is because we want the least amount of things as possible coming up as part of Terraform, right? We want the bare minimum, and we want the majority of the stuff to live in our Flux repository or our GitOps repositories that get leveraged by Flux, because it's going to make the changes a lot easier. Rakesh asks, do you do etcd backups as well? So no, we don't. We have a very specific way that we bootstrap etcd. That's probably a separate kind of talk. What I'll do at the end is I'll go to the Medium links. I actually have a Medium blog post on how we do etcd bootstrapping. And we don't back up etcd because in a complete incident, we will just tear down the cluster and stand up a new one, and Flux will just reconcile everything back. Because really etcd is just the state of the system, but our state of the system is in Git, so we can always get back to that state. So finally, I want to kind of leave these links on here for a couple of seconds for you to take some screenshots. So the top half of these links are repositories that we're going to use in the demonstration. So customize Flux and the Helm operator. And then the bottom half is, the first one is an example of the policies that we created for deprecated Kubernetes versions. The second one is an example repository that we're actually going to use now. And then the one at the bottom is the Medium blog posts that go into a lot more detail. And Rakesh, there's a blog post there that will go into detail and answer your question about etcd backups. So I'll stop there for a second before we go to the demo and just kind of open it up for a couple of questions, if anybody has any, before we go into the demo, and mainly so I can have a quick drink. Okay, so if we have no questions, let me change my screen. So what we're going to do today is we're going to use this repository, and I'm going to kind of show you this in action of how the whole thing works. So over here we have a Kubernetes cluster with a couple of nodes. I'm using K3D in this example from Rancher to provide us with a target Kubernetes cluster for us to deploy to. So let's take a look inside of scripts first. So inside scripts, we're going to tell the Flux instance that we deploy that we want it to look at the customize/dev directory. That's the directory that we're going to deploy and we're going to reconcile. And then we are going to install Flux, and we're going to point Flux at a specific repository and branch, and a specific path. The key thing to note here is this line here. So you need this line here if you are leveraging customize.
Steve, sorry to interrupt, but can you zoom in? Yeah, thank you.
No problem. So you're going to need this line here. The reason why you're going to need this line is because customize is going to be the thing that creates our YAML files, right? They're not going to be totally complete YAML files inside of our Git repo. So we're going to deploy Flux. Then we're going to deploy the Helm operator. And then as part of Flux coming up in this scenario, Flux is going to create us a GitHub deploy key. And what we're going to do is we're going to add that GitHub deploy key to our Git repository. That's going to allow Flux to establish a connection to the repo. And then Flux is going to reconcile everything in the repository that we need. So I'm not going to run this just yet because I want to go back and show you the repository structure. So we have customize here. We have a base directory. We have a number of different things that are coming in here. So let's just look at inside cluster. We've got namespaces. So we're going to deploy the platform system namespace, and we're going to deploy the sealed secrets namespace. The key thing to note here is that how customize works is it looks for customization.yaml files at the base directory that you're targeting, and then works backwards up to base. So in here, you'll see that for the cluster directory, we are going to pull in the resources that are in all of the folders in the same directory as our customization.yaml. And then if we go to dev, because this is the one that we're targeting, dev has another customization.yaml. and it's going to pull in the directories that are within the directory that we're in right now. So let's just have a look at cluster, for example. So cluster has another customization.yaml, and it simply points back to the base directory and wants to use the cluster subdirectory. So in this example, we are doing, we're just taking the resources from base and we're just going to use them. Rakesh is asking, how many nodes does the cluster go to typically? So is that at Metal specifically that you're asking, or is that just generally in this example here? Whilst Rakesh answers that, let's just go to an example where we have some kind of patch. So if we look at monitoring now in our customization, we're going to pull in the monitoring directory from base, which has a Grafana Helm release, and then we're going to do a strategic merge. And this strategic merge is going to be using the file Helm releases Grafana. So if we go to Helm releases Grafana, what we are doing here is we are going to add the environment specific config to Grafana. So we are going to say, okay, well, we're running in dev here, so we need to pass it in grafana.monitoring.dev for both TLS and ingress. So that's how you kind of do an override. So what I want to do to start is I want to show you a couple of commands that we can run locally. So inside customize, we have to have a .flux.yaml. And this .flux.yaml is essentially telling Flux what command it should run every time it syncs the repository. So for those of you who are familiar with customize build essentially creates all of the resources that we want to deploy to the cluster. So that's the command that Flux needs to run inside of the Flux instance before it deploys it to Kubernetes. So Rakesh's question is, how many nodes does the cluster go to at Metal specifically? So we have 3 master nodes, 3 ingress nodes, 5 etcd nodes, and then it can range anywhere from 25 to 35 worker nodes, and that depends on what that environment is being used for. So we have auto scaling groups for all different types of workloads that run. So we have specific worker nodes for Kafka, we have specific worker nodes for monitoring, and then we have a couple of other specific worker nodes for different types of workloads that run as part of Metal. So we know that inside Flux, we're going to be running a customized build. So for local development, we need a way of being able to see what Flux is going to deploy. So inside the make file here, we have a test. And what we're going to say is perform, let me zoom this in a little bit, perform a customized build looking at customize, and this will just be dev, and pipe the output to a file _test dev.yaml. And that is going to be the output of what Flux is going to reconcile. So let's do this locally. So if we run make test dev, and then if we vi dev.yaml. So you'll see here, this is all of the directories that are...
Steve, can you zoom in a bit more, or 2x to 3x?
Sure. Is that better?
Yeah, it looks better.
Okay, so if we look down here, you'll see a number of different resources that are going to get deployed. And then if we look for Grafana, if we come down here, we'll see now that our host name for Ingress for Grafana has been applied. So that patch has been applied. And now this is what we're going to get. We're going to make sure that we have the dev Ingress host name. So this is just a good way of being able to see this running locally. A couple of things to note here before we go any further. The customized version that runs inside of Flux is using the customized binary. There is a customized plugin that comes as part of kubectl. It doesn't use that one. It uses the normal customized binary. So customized version. So this is 3.8.1. When you're using Flux, you should look at the Flux, the customized version that is aligned with the Flux version that you're running, and then make sure that you're using that locally. So let's run the script. So if we run make install Flux, so this will take a little while. We're going to be installing a Flux instance. We're going to be installing the Helm operator as well now. So this is just the initial stand-up that we do as part of Bootkube, but we don't deploy the Helm operator. We just deploy Flux. So the Helm operator stands up. Okay, so now Flux has given us a deploy key. So now what I need to do now is I need to put this deploy key into our repository. So I add this deploy key as part of this repository. I click add. It allows me to do that. And now we're ready. So we've bootstrapped. So if we do kubectl get pods -n flux, we can now see we have a Flux instance running. We have a Helm operator instance running, and we have that Flux memcache. So that memcache is going to be there for us to look for new image tags. So now if we do k get namespaces, or let's do kubectl get namespaces, you'll now see that we have things that are starting to get deployed. So we've got another namespace called cert manager. We've got a namespace for our Flux secrets. So this is all coming in via Flux. Flux is sitting there reconciling. So let's take a look at the logs from Flux. So kubectl logs -n flux. It'll be quite noisy, but let's just take a look at a couple of these things. So if we go to the top, we can see it started. It's established a connection with our repository. It's polling for new images. And then what we'll see down here eventually is here is the first sync that happened. So it counted the fact that it was deploying 34 workloads. It ran the kubectl apply, and it applied those manifests. And then if you look, it's constantly doing a sync. So it's constantly syncing that repository on a regular cadence. So Flux has done its job. So let's take a quick look at the Helm operator. So kubectl logs -n flux. Kubectl logs. I think my cluster may have died. Okay, so let's pipe this to gitops.yaml. Export. Okay, we're back. So kubectl get pods-n flux. Kubectl get logs-n flux. Yeah, I think what's happened is that the cluster that I have is too small. I think that's what's happened. So what we can do is if we do kubectl get namespaces, we should be able to remove some of our, okay, so let me do this. K3D create. Yeah, I think this cluster is too small. Okay, so let me do K3D make. Okay, I think I'm going to end this because I think I've lost. I think my Kubernetes cluster is too small to be able to handle this. Yeah, I think my Kubernetes cluster is too small. Oh, that's a shame. So instead of showing you some bits and pieces about that, let me show you a couple of the CI checks that we do. So as part of the CI checks that we perform a check that is our deprecation check. So what we're essentially doing is we're running this deprecation check inside of a container that has the deprecation policies already applied. So how we do that is we essentially do a customized build, the same as what Flux is going to do, and then we run conf test against it. So for those of you who are not familiar with conf test is essentially a way of being able to test the configuration against a set of rego policies. And then if we actually go to one of these directories, I will show you an example. So we have a number of rego policies in here. So let's just take a look at the 116 rego policies. And we essentially say that we do checks such as if you have any resources that are using these APIs, then those have been deprecated, and we deny this this manifest or this resource from entering the Kubernetes cluster. And we tell them specifically that they should be using the apps v1. So we have a number of these for all of the different resources at different versions. So you can use this container if you want to for your work. It's essentially a container that has all of these packages installed already in them and allows you to be able to run a set of checks against them. So if you want to be running kubeval locally, you can do that. Or if you want to be running customize, you can do that as well. So Satish is saying, what is the purpose of the rego of the deprecation checks? So the purpose of those is, if you imagine we have a number of developers that are deploying Helm releases, and they don't all know about Kubernetes, right? But from Kubernetes 1.14 to Kubernetes 1.16, there was a lot of deprecated APIs. So you can see that from here. If we go back to our policies and we just look at 1.16, all of these policies here are to make sure that you're not using deprecated APIs. So if we deployed and restood up a new cluster looking at Kubernetes 1.16 and allowed the developers to still use the 1.14 manifests, they would all fail because they were using deprecated APIs. So what we're doing now is we are making sure that we can upgrade the platform to new versions of Kubernetes and still use the same manifests without any issues. So it's essentially staying ahead of the upgrade curve. So if you think about what I was saying before, we're running Kubernetes 1.17, but our checks are going all the way up to and including 1.20. So in 1.20, they're deprecating some other resources as well. So they're deprecating ingress from using extensions v1 beta 1, and they're telling you to move to networking k8s.io v1 beta 1. So what we do now is inside of our Helm charts and our repositories, we're already using this API version. And that just means that when we upgrade, we don't have to make any changes. So I think that's all I've got for today. I'll open the conversation up for some questions. Does anyone have any questions? Prakash, can you still hear me okay?
Yeah.
All right. So
yeah.
thanks, Steve, for.
Does anyone have any questions? Prakash, can you still hear me okay?
Yeah.
All right. Okay. Yeah. Sorry. There was some technical problems on my end. So yeah, like if we have questions, I think there are questions coming. Like yeah, deprecation check was taken care of, and yeah, Satish is asking if you run your own channel, like YouTube channel and stuff. So
yeah, no YouTube channel for me. If you guys want me to create a YouTube channel, then I can try. Can you install? So Indira is saying, can you install Flux on one cluster and deploy applications to another cluster? No. So the Flux instance that gets deployed is talking to the Kubernetes API where Flux is running. So the next kind of demo that I'm working on, if anyone is familiar with Cluster API, I'm actually working on a demo whereby we have an infrastructure Kubernetes cluster and a Flux instance that will reconcile cluster API manifests, and then we'll essentially construct Kubernetes clusters in Amazon. That's the kind of next demo that I want to work on.
Right. So, yeah, I think if there are more questions, please reach out to Steve on his Twitter handle. It's we have tweeted a lot about the information and insights from the talk while he was presenting. So you can find his Twitter handle there. And so yeah, thank you for the talk, Steve. It was really insightful the way your infrastructure is set up. I learned a lot, like specifically Helm operator was something I'd like to take a look at, and because we at our company also use Helm, not directly, but underlying like as a library, and then Helm operators could be something that we could use inside the cluster itself. So thank you. But yeah, before we drop off, I would like. Do you mind, Steve, sharing your presentation over Twitter?
Sure, I will. I'll upload it to SlideShare, and then I'll send it to you, and then we can upload it to the Meetup link.
Awesome, thank you. That would be great.
Rakesh is saying, what pod networking do you use? So for what pod networking do we use? We use Calico. So if we go back to the presentation, we have a repository that contains our Calico network policies, and then we have a Flux that is responsible for just reconciling that repository. So that allows us to be able to make sure that only certain pods can talk to certain other pods. So kind of working towards a zero trust implementation.
Cool. So yeah, we do this after every meetup. We encourage people to join the Kubernetes Slack, and you can do that by going to the website slack.kts.io. You'll see it on the you'll see the link here on the YouTube, and please join, get an invite and join there and ask questions. Like you'll find all of us there on various channels. There are India specific channels as well. They start with in hyphen, and you ask there, or you go to project specific channels, or like SIG special interest group specific channels. So please join. It is really helpful. You find us you'll find us active there, and you'll find most of the developers of Kubernetes, upstream developers as well. So anything that you have, you can reach out. So that's there. Now, finally, so if you folks who are listening to us on YouTube, if you have any feedback, please tell us over Twitter or on Meetup group. Anywhere is fine. And our Kubernetes, our Twitter handle is KTSBLR on KTS for Kubernetes and BLR for Bangalore. And yeah, if you want to talk like this in a virtual meetup, please reach out anywhere, and we'll make sure that you can talk and stuff like that. And anything else, please reach out. Please tell us what it is. So yeah, thanks for joining us, and thank you, Steve and Prakash. Thanks.
Thanks all.